This is a video record for probability and stochastic process homework 4, question number 1. The problem setting is we need to find out the value and draw the sketch of capital letter f of y, fy of y, and lowercase fy of y in terms of capital fx of x and lowercase fx of x. And we are given the value of y, which is equal to g of x. It's equal to 2 for the case where x is less than 0, and y is equal to 0 for 0 is less than or equal to x, which is also less than 1, and y is equal to minus x plus 1 for x is between 1 and 2, and y is equal to minus 1 for x is larger than 2. To determine the value of both the function, the density function, and the distribution function of y, we first drew out the graph for the y equal to g of x. As you can see, the graph is here as illustrated, where x is y is equal to 2 when x is less than 0, and when x is between 0 and 1, y is equal to 0. And when x is larger than 2, y is equal to minus 1, and x and y satisfies the relations where y is equal to minus 1 plus 1 during between x equal to 1 and 2. So the value domain of 1, as we can see, that is from the graph, is between minus 1 and 0, and also y can also be 2 in this case. And so the capital F of Fy of y is equal to 1 when y is larger than 2, and when y is less than or equal less than minus 1, Fy of y is equal to 0. And also according to the graph, when y is equal to minus 1, which is in this case, and the first case we talked about in the first case we talked about when y can choose between different values. And according to the graph, when y is equal to minus 1, we can get the probability of y equal to minus 1 is exactly the probability of x larger than 2, which is in this case. And it can be rewritten as 1 minus capital letter x, fx of 2, of 2, and this can be like rewritten in this situation. Similarly, we also write different situations and different probability values when y is equal to different values. When y is equal to 0, the probability is exactly in this part where x is between 0 and 1, and this is equal to capital F of x of 1 minus capital Fx of 0. And when y is equal to 2, the probability of y equal to 2 is equal to the probability of x less than 0, and it's equal to capital Fx of 0. And so, and when y is between minus 1 and 0, we can also rewrite it to be like this. The density function of y is equal to the density function of x of 1 minus y. So to sum it all, we have to calculate out the distribution function for this situation, and we can get it to be here when capital F of y of y is equal to the probability of y less than or equal to y. It's equal to the probability of 1 minus x, which is less than or equal to y, and it's equal to the probability of 1 minus the probability of x less than or equal to 1 minus y, and it's exactly equals to 1 minus capital Fx of 1 minus 1. And so to sum all, we get the distribution function to be here, where in this case we get the value directly from this equation, and we can get this value directly from this equation when y is equal to 2, because when the situation where y is between 0 and 2, it's actually there's only one case where y is equal to is exactly equal to 2, and when y is less than minus 1, the distribution function is absolutely 0, and when y is larger than 2, the distribution function is absolutely equal to 1. And for the density function, we can get it directly to be get from those situations that we'll talk about, and just note that for each case we get the distribution function, we multiply it by a impulse function where y is equal to those values when y is equal to -1 and y is equal to 0 and y is equal to 2. So this is the end of this problem 1.